Hey there, ladies and gentlemen, and welcome to Chapter 9. Chapter 9 is about the quadratic equation and being able to solve and graph and all those fun parts. So we're going to get started right away here. This is kind of a longer lesson for us, so we've got to make sure that we keep moving here. Our big goal is being able to graph all parts of the quadratic equation. You're going to want to have some of this stuff written down in your notes for what they are. The parent function is where all graphs kind of come from. So when I have the form in standard form of this ax squared plus bx plus c, the bx and the c are things that just change from the parent function. So the parent function is where all graphs start. It's kind of like when we did linear equations where we had y equals x, and that was the parent function. Things would either get more of a steep line, they'd change to being positive and negative, or they'd shift up or down or left or right based off of what happened in the equation. Same things are going to happen here with our parabolas. So there's parts of the parabola called the axis of symmetry. The axis of symmetry comes from this equation right here, where it says the opposite of b divided by 2a. The axis of symmetry is that line in a parabola where it's the symmetrical line, where your half of your graph of a parabola is to the left and half of the graph of the parabola is to the right. If you think about folding a parabola, the U-shaped graph, onto itself, the axis of symmetry is that spot where that's going to fold onto itself. Now the y-intercept is when x is equal to 0, and that happens in our standard form at c, because if I put a 0 in for x, just the c is left over. So that's going to be our y-intercept. And then depending on what type of graph we have, we're going to have either a minimum value or a maximum value. So we're going to have a maximum value if we have a parabola that looks like this, because they'll have a vertex up here, which is the maximum value. Or it will have a minimum value if our parabola is opening upward, because that's the smallest value that we could possibly have. So that would be my minimum. So it's the point where the parabola peaks or bottoms out. It's called the vertex. So that's very, very important that we know that that's the vertex. So we need that specific point. We also need to know this axis of symmetry to find that specific point. So those are things that are going to be helpful for us. And we're going to get started with our first example. All right, so our job is to graph this equation of an x squared minus x minus 2 using a table of values. We're going to identify the range and the domain. Remember from lessons past, range is the y values, domain is the x values. They go alphabetical, x then y, d then r. So it's kind of an easy way to remember things. So what we can do is we can plug in, let's see if I can get all this in one swoop here. We can plug in the values of -2, -1, 0, 1, and 2 like we did in units past in for the x to figure out what the y is. And then we'll be able to prove that our axis of symmetry is what it is. So I'm going to use my trusty calculator. I'm going to put every single one of these numbers in parentheses when I type them into the formula so that I get exactly what I want to have happen. So I'm going to put in this parenthesis, a -2 to the second power, parenthesis, minus a parenthesis, -2, minus 2, and I get the answer of 4, a -4. No, I should get the answer of 4. There we go. And when I have the -2, so to the left, 1, 2, and up 4. 1, 2, 3, 4 is one of my points. Now, when I plug in this +2, I should also get that exact same value. So let's check it out. A 2 to the second power minus 2 gets me to a 0. Oh, we must not have ourselves an exact parabola going through the 0, 0. So we're going to have that issue going on. To the right, 1, 2, 0. All right, let's plug in the next one, -1. So I have a -1. So in my parentheses, I have a -1 to the second power minus a -1. And this is a lot of calculator work. Minus 2 gets me to a 0. Okay, so at a -1, we also have a 0. So to the left 1, we put a 0. Now, because of that, I should be able to determine about halfway between these 2 points should be my axis of symmetry. Let's find out if we can find it here. Now I'm plugging in 0. 0 squared minus a 0 minus 2 should be at a negative 2. So I go down 1, 2, put a dot. And then I have my 1. 1 squared is 1. Minus 1 is 0. And then we have a negative 2 for that one as well. Okay, alrighty. So we're finding out that we should have a halfway between these two should be my vertex. So let's plug it on. Our axis of symmetry formula was the opposite of B over 2A. So B is right here. It's the number in front of the x. A is right here, the number in front of the x squared. And C is, in this case, a negative 2. So I'm going to plug those things in. So the opposite of a negative 1 would just be a positive 1. And then 2 times a 1 is just still a 2, or just a 2. So we get left with a half for my axis of symmetry. Axis of symmetry is when x equals something. That's going to make our vertical line like we learned way back when. And I'm going to have my axis of symmetry, so half of my parabola is right there. And I'm going to sneeze. Oh, excuse me, folks. So normally I should have hit pause there, but I didn't. So my axis of symmetry is at 1/2. So if I plug this number of 1/2 back into my equation, I'm going to find my y value so that I can get my ordered pair of the vertex, which will be at a 1/2 comma whatever the answer is when I plug it back in. So I'm typing on the calculator. I'm going to have my 1/2 to the second power minus 1/2 and then minus 2. And I get a negative 2.25 or a negative 2 1/4. So I'm going to go down 1, 2 1/4. I should have that be that same blue color. There we go. And then that is my parabola. Now, what I'm going to do is I'm going to connect my dots here, knowing that this makes a U-shaped graph. Even though it kind of looks like a V, it's a U-shaped graph, so don't make it V, make it a rounded turn. And that is my parabola. My domain are the x values. So if I look at the x values from left to right, my domain is going to be all real numbers. And it's all real numbers because this is going to get wider and wider and wider as it goes up and up and up and up and up. My range is my y values, and they go from where y is greater than or equal to that negative 2 1/4 that we found right here from my vertex. So that's going to be my range values. Now you can see this is going to take a little bit of time, folks, right? So you got to be able to plug those numbers in and figure everything out. We're going to get real quickly through this example where we just have to find the vertex, the equation of the axis of symmetry, and the y-intercept. So let's call those things part 1, part 2, and part 3. So the vertex is just this point right here. We just look at it. So the vertex is an ordered pair answer. That was to the right 2 and down 1. So I just had to look at it to find it. My axis of symmetry is going to be my x equals line. So that is going to be, I'll put that in purple. That's this line right here. And that's going to say where x is equal to the right 2. And that's also the x value for my vertex. Now my y-intercept is I'm just going to travel along my parabola and I'm going to find where it crosses. And it crosses right here. And right there is where x is 0 and y is 2. So my ordered pair for the y-intercept is at 0, 2. And again, your ordered pairs are always going to have nice numbers here for us, hopefully, so that you can make things look really, really easy. So you'll try this one quickly on your own. We'll check it tomorrow when you get back to class. And then we will do this one in class right now. At least part A we'll do together. Part B will be on your own that we will check when we get back to class tomorrow. So our job, example 4, is going to be a little bit more difficult than what we did before. So we are going to be plugging in to find the vertex, the equation of the axis of symmetry, and then the y-intercept. Now the first thing that you're going to find, they're going to be in this order. You're going to find your axis of symmetry equation, then you're going to find your vertex, and then you're going to find your y-intercept. Okay, so that's what you're going to find them in that order. Opposite of b means that we're just going to look at what the value for b, in this case it's a -8, so the opposite of it would be a +8, and then over 2 times our a. Our a was a -2. So then we do this math and we find out that this is equal to an 8 over a -4, which is equal to a -2. So my axis of symmetry equation is going to say x is equal to -2. Now that's important. That's step 1. Now I'm going to use that -2 as my x value and I'm going to plug it into the equation. So I take my trusty calculator. I type in -2 parenthesis -2 parenthesis to the second power minus 8 parenthesis -2 parenthesis minus 2. So I type it in like that and I get the answer of 6. So then I put a 6 up there for my y value of my vertex. So my sketch of this parabola is going to be looking like this. This is going to be at -2, 6. Now my y-intercept is just me plugging a 0 in for the x value. So all that makes 0, all of that makes 0, and my answer is at a -2. So that's the process here, folks, for finding all of this information. You're going to do the exact same thing for question B in your notes, and then we'll check it and go over it in class tomorrow. All right, folks, hopefully this wasn't too bad for you. Check it once, check it twice. This is the Berman Nation. I'm signing off.